As I'm grading some of these mole quizzes, I had some ideas, so I thought I'd kind of just bring them up. So one of the ideas, and have success with doing these mole problems, first thing, just in general, don't give up. We have, a lot of stuff. When you see the pattern, it is really going to start making sense and click in there. So some of you have already seen the pattern, some have not. So just keep working at it, and it will come, because we need this topic. You need to be able to go from moles throughout the whole course. A big thing we're looking for here are the different clues that are in each problem. So some of the things, look at the units. The units are very important. So they kind of help you where to get started, help you how to finish, they help you how to go from step to step. And the other part here is think. So read carefully, and when you see the problem, think about what it's actually saying so that you know how to go to the next step. So we're going to look at one of the quiz questions. So we said aluminum sulfate is a solid used in purification of drinking water. A 29.5 gram sample of aluminum sulfate is obtained. Well, the first thing I would do is go through and rewrite this, either physically rewrite it or just rewrite it in my head. So I know I have 2 aluminums, that's easy. And SO4 taken 3 times means I have 3 sulfurs and 12 oxygens. Now the next part is standard. So we have, look in the periodic table, we see that the aluminum weighs 26.98, that sulfur weighs 32.07, and oxygen weighs 16.00. And I have 2 aluminums, that should be a 2. We should have 3 sulfurs and 12 oxygens. So I did do this part correctly. So that's 2 times 26, that's 3 times 32, and 12 times 16. So altogether it's 342.17 grams per mole. So there are 342 grams of aluminum sulfate in 1 mole of aluminum sulfate. Well, our next question was, how many molecules of aluminum sulfate are in this sample? So here's our sample. So we're going to start here. Now that's grams of aluminum sulfate. Now if I have my grams of aluminum sulfate, what do I know? Well, I know that there's that many grams in a mole, and I'm going to jump over here, that here's our mole map, and we know that if we start with the mass, or we start with the grams, then we can change to moles, and we could change from moles to the number of molecules, we could change from moles to the volume, or we could just stay with moles. But the idea is, wherever we start, then we're going to want to go to moles. That way, then, that's kind of our central location. So if we have any kind of information like grams, we want to find moles, and then we're going to go to molecules. So we're going to go from grams to moles, and then moles to molecules. So how many molecules of aluminum sulfate are in this sample? Well, I know that there's 342 grams in 1 mole of aluminum sulfate. Now, these units cancel, and you can see that the units help me show up where I need to put each of my little items. I know that if I have grams here, I have to have grams here, so they cancel. Well, 1 mole, I need to have moles down here. Now, if I want to get to molecules, hopefully we know molecules in moles. That's Avogadro's number, 6.02 times 10 to the 23 molecules for 1 mole. So all we have to do now is work out this problem, and we'll have the number of molecules. I'm getting 5.19 times 10 to the 22 molecules. Let's put a box around that answer to make it easy to find. So far so good. We can see what we're doing is we're using our units, grams and grams, moles and moles, and we're left with molecules, and molecules what we're trying to find, so we know we're done. Now the next piece says if the density of aluminum sulfate is 2.672 grams per cubic centimeter. So again, there's some units I want to find. Find the volume. Okay, well, what's the volume? The volume could be liters. In this case, the volume is going to be cubic centimeters. So I'm going to try to start somewhere and get to my volume. Well, I'm still talking about the same little sample, so I can start down here with 29.5 grams, and I need grams down here. So what do I know? I see they just given me 2.672 grams. Now that's not how many grams in a mole, that's how many grams in 1 cubic centimeter. So anytime I have something per something, I can use that as a conversion factor. In fact, that's all I have to do. So grams cancels out, and I'm left with centimeters. So I just have to do this problem real quick. And I'm coming up with 11.04, so I'll just call that 11.0 cubic centimeters. So that's my next part of the problem here, where here I have density, and it's, that's kind of an odd thing to throw in. We haven't been using that for a while, but anytime I know something per something, I can use that as a conversion factor, and that's exactly what I needed to do. Now the last part here, how many moles of oxygen atoms are in the sample? How many moles of oxygen atoms are in the sample? Now I saw a lot of people do all kinds of odd things like trying to use, the mass of oxygen, and that doesn't seem like a reasonable thing, because what I have 29.5 grams of aluminum sulfate, and if I said, okay, well, how many moles of aluminum sulfates do I have? I could change grams to moles. That would be okay. I could go from grams and go to moles, and that's just going to be one step. But from that moles of molecules, then I should be able to go to moles of oxygen, because I have the formula, and I know that in my formula for every one of these I get 12 atoms. So there's a 1 to 12 little relationship that I'm going to use. So let's try that. So let's go ahead and start from the same place. 29.5 grams of aluminum sulfate. And I want to go from grams of aluminum sulfate to moles of aluminum sulfate. And I know that that is, 342.17. And now, just thinking about it, just making sense of this, that I know if I had a mole of aluminum sulfate, it's a little sloppy, I would have 12 atoms, well, 12 moles of atoms of oxygen. So that's terribly sloppy, sorry. So 1 mole of this aluminum sulfate would give me 12 moles of atoms of oxygen. So all I have to do is take my other answer and multiply by 12. So let me go ahead and calculate this. And I get an answer of 1.0345. So I'll just say 1.03 moles of oxygen atoms. And again, I'm using my given value, and I say, okay, I know grams here, so I can go from grams to moles. That's usually a first good step. And then just thinking about it, I say, okay, if I have a mole of these molecules, then I have 12 moles of oxygen atoms, because that's what the formula means, and then get my answer. And that's all there is to this one.